Hello, advanced math students. What we're going to start talking about today is data analysis. This is going to be the beginning of our new unit where we focus all about how to analyze data. So what I want to do today is really review a couple ideas with central tendency and talk about how to make a thing called histograms as well. So we're going to start with the histograms piece. This is a graph, and a lot of times people confuse these with a bar graph. It's not a bar graph because a bar graph shows each individual entry with a bar for it. A histogram instead shows range of entries. And here's a big thing. The y-axis on a histogram is always the same thing. It's always frequency. So a histogram is actually what we call a frequency distribution. It shows how much of a certain interval happens. How many entries are there in that interval? So we're going to look at an example with GPAs here. I've got a bunch of GPAs listed here, 12 to be specific. And we're going to see if we can arrange these GPAs into a histogram. Now, the very first thing if you're going to make a histogram is deciding on an interval that makes sense. We don't want to have just like one bar. That tells us absolutely nothing about the data. But at the same time, we don't want to have like 800 little bars here to where basically we don't want to have 12 here because that's just a bar graph. So what we're going to do is we're going to cut this into intervals along this x-axis in things that make sense. Now on this one, our lowest we've got is 1.7. Our highest we've got is 4.0. I think if I go by 0.5s for my intervals, that would be the most sensible option here. Now, I can't tell you exactly what you should do on every histogram. It matters, or it's based on what your data is. If your data is really spread out, going by 0.5s would make way too many pieces, make way too many intervals in your histogram. So it just depends on your data. So for this particular one, 1.5, or going by 0.5 is pretty good. Now, this little thing here is a handy little thing to put in graphs. I don't really want to start at 0, because if you notice, I'd have to go 0 to 0.5, there's not any of those. I'd have to go 0.5 to 1, there's not any of those. And so I'd rather just skip ahead a little bit. This little symbol means there's a break in the graph. So instead of starting at 0, the lowest we have is 1.7, so I'm going to start this at 1.5. And I'm going to go from 1.5 to 2.0. That's going to be my one interval here. Now, 1.5 to 2.0, let's go over here and look at how many fall in that range. Because remember, on the y-axis is frequency. How many of those are there? So from 1.5 to 2, we've got a 1.7 right there. We've got a 1.9 right there. We've got 2. And so I'm going to make this bar go up to 2. Something that's different on a histogram and a bar graph as well. A lot of times, this doesn't have to be the case, but a lot of times histograms are made so the bars are actually touching each other. Whereas bar graphs, you separate them. There's a little gap between them. And so sometimes that's done as well. And so the next interval is going to go from 2 to 2.5. All right, so let's look at our information over here from 2.0 to 2.5. We've got 1 right there. And do we have any more? I think that's it. So this one is only going to go up to 1 from 2.0 to 2.5. So I'm going to go from 1 right there over and straight down. So there's only 1 from 2.0 to 2.5. Now I'm going to go 2.5 to 3.0. All right, so let's look over here at our data. 2.5 to 3.0. We've got 1 right there. We've got 1 right there. We've got 1 right there. Now we have to think a little bit. You notice we've got a 3.0 in here. So far I've counted 3 that are in that range. Does 3.0 count in this one, or does it count in the next one? Well, the way that histograms always work is if our interval is from 2.5 to 3.0, it's from 2.5 including the lower number. Remember our little interval notation, bracket means include it, parentheses means don't include it. So this interval actually says from 2.5 including 2.5 all the way up to 3.0 not including 3.0. So that means we've got this 1, 2, 3. The 3.0s don't count in this one. They're going to be in the next group. So I'm going to go up to 3 on this one. Crooked there. There we go. All right, so that takes care of that. And then our next one is 3.0 to 3.5. And remember, the 3.0s are going to count in this one because we count the bottom number, we don't count the top number in the interval. So we've got 1, 2, 3 in that range. And so we're going to be the same place we were on the last bar. We're going to be up 3 for the frequency because we have 3 things in that interval. And then we're going to go 3.5 to 4. So between 3.5 and 4, we've got 1, 2 people's GPAs. Remember, the 4.0 can't count there. So this is going to be a little weird. We're going to have to make an extra bar for the person who has a 4.0. And so I know that you can't actually get above a 4.0, at least on our grading scale. But for that person who has a 4.0, they can't go in the 3.5 to 4.0 range. And so they're going to be over here by themselves in the 4 to 4.5. So there's a histogram of that data. Now remember, these are all intervals, and the vertical part of this is how many fit in each interval. It's a frequency distribution. It's showing how many things, how many sets of data or entries of data fit in that interval of numbers. So that's the idea of what a histogram looks like. All right, now the other thing that I wanted to do today, goal number 2 basically, is looking at measures of central tendency. Now this, as far as how to find them, should be review. This is something you guys have learned before. But what I want to do to kind of extend on that thinking a little bit, I'm going to introduce you to a little bit of notation that goes along with these that we're going to use farther in this unit when we get more into our data analysis. I'm also going to try to, instead of just saying find the mean, median, and mode, I want to talk about which one is best in certain situations and why. Now, if there was a best one always, only one would exist. There would be no need for the other two. The reason that more than one measure of central tendency exists is because, depending on the circumstance or the situation, one could be better than the other. So let's first talk about mean. And this is a new symbol. I don't think you guys have seen this before, but new symbol for mean is X with a bar on the top, X bar. Another word you've probably heard for mean is average. And the way we find the average of a set of data is we just add up all the pieces of data that we have and divide by the number of entries we have, which is really all this says. So here's a formula for how to find X bar, the mean. So this says add your first entry, your second entry, your third entry, all the way until you get up to the nth entry, or the last entry, and then divide by n, where n stands for the number of data entries. And so if you have 50 pieces of data in this set, then n would be 50, and you have to add together 50 numbers and divide by 50. Right? So that's how we find average or mean. Median. The median is just the middle number if you arrange all of your numbers in ascending order, or descending order for that matter. And so if you just put the numbers in order lowest to highest, that number that falls right in the middle, that's the median. And if there's 2 numbers that fall in the middle, like if you have an even set of numbers, then there actually are going to be 2 that fall in the middle. In that case, you take the average of those 2 in the middle. And then the mode is just the one that occurs the most. It's the most frequent number. Right? And there's some sets of data where all 3 of these would be about the same number. It just depends on the set of data. There's some sets of data where these 3 things vary by quite a lot. And which one you report is really kind of based on what you're trying to get people to know and how ethical you are as a statistician as well, because you can really do some stuff with statistics to make your viewpoint seem more likely than it probably is. And that's kind of what I want you guys to be getting out of this unit, is to be good consumers of data. When you see data, be able to look at it in detail and say, is this accurate reporting, or are they doing some things that are maybe true according to the numbers, but not really representative of what's happening here? So I want to give an example where we talk about that just a little bit. So in this example, here's what we've got going on. You are the person who runs a small software company, right? So you're like the owner of this software company, and you're looking to attract new employees. So you're trying to get employees to come to you. Here are the salaries of your current employees. So we've got 8 employees at the place. Now you're the owner, so this is probably you. You're raking in the big bucks. You've got like kind of a manager who's making also quite a lot of money, And then we got some more common salaries here. So the question I have is, what should you report? Let's say you're posting this on some website to attract employees. Should you post the average or mean income? Should you post the median income? Or should you post the mode income? Now remember, if you're the owner and you want to attract employees, you want the income to seem high. You want this average salary, or the typical salary, we should say, to seem high. So let's compute all three of these and see which one would be best for you. So let's do the average first. Now remember the way average works. You add all of these together. And so I did this just a minute ago, and so that plus 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 that, add them all together, there's 8 total. And so adding all those together and dividing by 8, you get that the average, or X bar, comes out to $158,750. That sounds pretty good. All right, if we're going to do the median, well, the median is just the middle number if we arrange these in ascending order. Now, rather than like take all these things that are all in jumbled order and rewrite them all, here's what I'm going to do. I'm going to just cancel out the lowest and the highest, and just keep doing that until we get the one left in the middle, or possibly the 2 left in the middle. So there's the highest, there's the lowest. All right? There's the second highest, there's the second lowest. All right? And then there's the third highest, there's the third lowest. All right, now since there's an even number of entries in this set of data, 8 entries, we actually have 2 numbers that fall in the middle. We don't have a middle number. Now remember, for median, what we do if there's 2 numbers that fall in the middle like this is we just take the average of the 2. And so we could add these 2 together and divide by 2. Or it's possible that you could look at 50 and 56 and just notice the number halfway between those 2, or the average, is 53,000. And so the median is 53,000. So that's the median income in this software company. And then the mode is the most frequent. So looking at these numbers, the most frequent salary, there's 2 people making $31,000. All right, so let's think about where you stand on this. You're trying to get employees to come work for your company, so you want to make it seem like the salary is as good as you can possibly make it seem. So you could say the average salary is $158,000 at your company, and you are telling the absolute truth. Now, is that really representative of what the typical person at your company makes? Not really. But are you doing anything that is untrue? No. Is it slightly unethical? Probably. But you are telling the truth. The average income at your company is $158,750. So this is kind of what I want us to really get, is this sort of thinking. What do we need to do to be ethical, and what do we need to do to be consumers of data that know when somebody's telling the truth, and when somebody's telling the truth in a way that benefits them, that is not necessarily representative. So let's flip this around for just a second. Let's say that you were somebody who worked at this company, and you thought the wages were way too low, and you were trying to bargain with the owner to try to get the wages increased. If that were you, you would probably use the mode and say the most common salary you're paying your employees is $31,000 a year. That's too low. And you're completely telling the truth. Now, which one of these 3 is probably the most typical of what an employee here makes? I would say the median is probably the best in this particular case, because it's the most typical of what an employee makes there. So I really want to get that idea down of what's best in what circumstances. Now, why is this so high? Because there's kind of a word here I want to throw out that's an important idea. This is much higher than the typical salary. The reason it's so much higher is because we've got a couple, especially this one, but this one as well, we've got a couple of pieces of data that aren't grouped closely with the other pieces of data. What we call those pieces that are way out there away from the rest is we call these things outliers. And when you have outliers, they make the mean no longer representative, because outliers affect the mean. Now, outliers don't really affect the median because we just cancel that out as the highest. If this were only 61,000, it would still be higher than that and it would still be the highest. So whether it's like 61,000 or 250,000, either case it's higher and gets canceled out when we're looking at just the middle number. So outliers do not affect the median. However, outliers do affect the mean. And so the big thing you should be looking for if you're trying to see if the mean is a good representation of the center is, are there outliers skewing that data and making the mean farther off than it should be? All right, so that's the ideas of mean, median, and mode, and how to interpret what that means when you find the mean, median, and mode. So that should be good for a start on data analysis. We're going to do a little bit more with this. Next to come, we're going to talk about measures of dispersion, so how spread out the data is. And then eventually we're going to get into trying to use this information in normal curves and computing that as well. All right, so that'll wrap it up for today.